Good evening, everyone. Thank you for the introduction. As Tracy said, this year slightly different to previous years for the Glossop Award, in that rather than presenting a case study, my challenge was to submit an abstract and then give a presentation on the topic, communication of risk and opportunity in engineering geology. This is obviously a huge topic and something that we're doing in our daily jobs and our lives. And in 15 to 20 minutes, I'll try and give a good description of that and some examples that I've seen in my own work. So I'll start with a bit of an introduction to current practice and why we must communicate. I'll follow that up with some of the challenges that are faced by our current practice, and then look at some of the best practice and innovation that we can apply to that current practice, and then look to the future and the challenges that might bring, and how I believe that we're ready to meet those challenges. So just to frame the topic a little bit, some simple definitions that you'll all be familiar with. A geohazard then, a ground attribute with the potential to cause harm or loss. A geological risk, the product of the severity of the geohazard and the likelihood of its occurrence. Risk typically denoted as having a negative outcome. And then conversely, a geological opportunity, which can be considered as attributes of the ground that make it possible to do something. Now, we don't think about opportunities as much as we do risks, and the two are clearly very closely linked. There's the risk that an opportunity isn't realised, and then there's the opportunity to mitigate a risk. But we tend to think more about risk, and these are the kind of reasons why. So, of course, unlike any other material, ground that we're dealing with, unlike anything else, it varies in lateral extent with depth over time and any load that's applied to it. And because we interact with the ground, it creates uncertainty. And of course, we must communicate that uncertainty to others. If the effects of the ground have a negative effect for health and safety or welfare, we're bound by legislation to mitigate and communicate those risks. And of course, we need to then assure our insurers that we're doing a good job of risk management as well. And of course, we're bound by the codes of conduct of our professional societies, be it the Geological Society or the ICE, to communicate objectively and without bias and with the interest of public safety as well. And I also believe that to exercise our duties with integrity, we're responsible for identifying and reporting opportunities. So with those three factors in mind, it's clear that if we effectively communicate risk and opportunity, we can reap some serious corporate and societal rewards, be that for sustainable development, business reputation, or cost program and various project benefits. And as engineering geologists working in civil engineering, in that sphere, I believe our ultimate responsibility is for the betterment and development of society. So current practice really for risk management was formalised properly by Clayton in 2001. And in the context of the geological life cycle of any engineering geological project, we identify hazards, mitigate those, communicate any residual risks within the individual stages of the project. In the UK, the highways industry has adopted this approach in document CD 622, Managing Geotechnical Risk, and that's also been adopted outside of highways because it's really a best practice document that lays out the steps to follow. And in that document, one of the key tools for risk communication and identification and mitigation is the Geotechnical Risk Register. So there's two key challenges, I think, that face our discipline that might be unlike some others. The first is the complexity of our discipline. Now, you don't have to be able to see all the elements of what's on the slide to notice from Fuchs' sketches in the 1997 paper, Geology for Engineers, just how complex the ground might be. And this is an example from a formerly periglaciated environment. So with such unique challenges like that, we're going to have to communicate in order to get our message across. And then, of course, we have very diverse audiences. So any single project might involve stakeholders, including politicians, the public, various experts on our project parties. And so communicating with these different groups, they'll all have different drivers, different opinions, and different understandings of risk. So we can't use a single style of communication. And even if we do communicate well, there'll always be those perhaps that decide to ignore our warnings. And I've included an example there. The BBC reported on a resident that returned to their landslide-threatened home in South Wales, despite a communicated risk to their life from landslides that had occurred previously, and despite the risk of a fine, which they later received. So the Geotechnical Risk Register, a key tool for communicating risk. I've included a simple example above. All risk registers really have in common that they identify a hazard, rate the undesirable circumstances, apply a mitigation strategy, and perhaps communicate any residual risk. But I think one problem here is that there isn't really an industry format for the geotechnical risk register. And as a result of that, there's a number of problems that can occur that I've seen. Some of those might include that the risk register is too generic, there might be variations in the assessment of likelihood and consequence, and then the quantification of the risk matrix might be different too. And we often find that our risk registers within engineering geology are different to those that another discipline or the project has used. So all of this leads, I believe, to poor communication. It can lead to misunderstanding of risk, lack of engagement of our audiences and the other parties. And of course, the geotechnical risk register is just that. At present, it doesn't include opportunities. So really, I think as engineering geologists, it's our role to identify those opportunities and start a bit of a mindset shift as to how we identify and manage opportunities. So some of the innovation and best practice from our own discipline, Glossop himself on the left there was a pioneer of this. He was one of the first really to identify the application of geology to engineering. And that was followed later by Clayton, who formalised some of the risk management processes, and later by Fuchs as well, who's advocated the use of 3D ground models in general. In the Netherlands, between 2009 and 2015, the GeoImpulse initiative managed to halve the reported incidence of geotechnical failures. And they did this by bringing together 150 people from 35 different organisations. They put together a load of different communication strategies. They pushed for the role of the site geologist. They emphasised the importance of the observational approach. And they pushed for ways to try and get geotechnical risk management into the contracts up front at the start of projects. In terms of public data, the BGS are providing more information online. They have their own jargon-free engineering viewer, which is freely accessible to the public. And as more open source data becomes available, I guess we're likely to see more of that kind of thing. And of course, the Geological Society is leading the way in knowledge sharing. In 2018, their Communicating Geoscience conference, one of the take-home messages is that we should learn from others who are already communicating well, particularly with the media. And in the engineering group conference, one of the take-home messages there was to use and apply social science to some of our communication strategies. And then only recently, in the Quarterly Journal of Engineering Geology and Hydrogeology, their Keeping the Lessons Alive special issue looked at how case histories can remind us of some of the problems that have occurred in the past. So we're in the midst of what some are describing as the fourth industrial revolution, which is being enabled by huge technological advances. And one area where I think this is making huge changes is in geological models. So going from a stage of 2D hand-drawn sections all the way through now to what is becoming common on most projects, a 3D geological model. And you can see if you look on the Quarterly Journal of Engineering Geology and Hydrogeology website, if you look at the most cited papers, the three most cited of all time all include either maps or models. So it just shows you how important that communication strategy and method is. So within Rock McDonald, we've been working closely with software developer Sequent to develop 3D geological models for our sites. And at the example site that you can see here, we were redeveloping a brownfield site. We had to put in a new channel, which would be retained by Gabion retaining walls. There was associated earthworks, a culvert under a road, and a drainage network to be installed. And I've included an extract from the model that you can see here. So starting with the LiDAR data that we'd acquired, we can set out the site. You can see 3 stockpiles on the site, a road at the top of the screen. We can drape over the satellite imagery for the site, so you not only get to see where the road is and the green areas being the vegetated areas of the site. We can plot on our borehole locations, which we're using another communication tool for data which is AGS format. And then we could apply our strata to those borehole locations so that we could start to build the model. You can see the borehole sticks come in there. Using the interpolation of the software and good old engineering judgment, we could then build the block model for the site. There it is. And then lastly, we could apply the Civil 3D model for the scheme, which will come in green now, which is the alignment for the new works to be proposed. And you can see the oval shape at the bottom of the screen is an attenuation basin, and the linear feature is the channel. At the top of the channel is the culvert. So we could start to build that model together. And then by stripping off some of the surface features, you can see some of the underlying geology. For example, the yellow patch, which is the alluvium. And what this allowed us to do was not only communicate with our own project teams, but also with the client. We were able to identify risks very quickly, such as where there might be soft alluvium at the retaining wall formation level, and also to identify some opportunities, such as to start quantifying what materials might be available for reuse in the scheme. So another area where I think that risk can be managed and conservatism can be reduced and opportunities can really be realised is during the construction phase of works. And I really think there's a very important role for the site geologist here. So between 2015 and 2017, I was fortunate enough to be the designer's geotechnical site representative on the A465 Section 2 scheme. This scheme in South Wales, 8 kilometres long, underlain by mine workings, karst features, areas of existing instability, very steep topography, huge number of problems to deal with. And to build and widen the road in that area required over 1.2 million cubic metres of earthworks and over 70 retaining walls. So whilst the client had recognised that geotechnical risk was a major issue, they'd involved early contractor involvement in the contract to start to identify and mitigate risks at an early stage. There was always going to be, despite a lot of ground investigation phases, geotechnical risks to mitigate on site. So something that was pivotal to my role on site was communication, both with the contractor and with the designer. So before we would start a geotechnical activity, such as soil nailing, like that shown in the photograph there, we would have a cross-party readiness review. We'd identify what could go wrong in terms of ground risk, and we would identify possibly what could go even better as well. So in the particular site that you can see, something that went not as well as planned is the potential for grout loss into the rock formation. But something that went better than planned was that we were able to shorten some of the nails, optimise the materials because of shallow rockhead, like in the area that you can see there. But with such a high profile scheme going on for such a long duration, the community had the interest as well, and I was able to engage with the public and with local schools by giving presentations on the geology in the scheme to those local community groups. So what about what we can learn from other industries? Well, in the natural hazards industry, you may have received a message like this before if you've been in an earthquake-prone area where you might be told to expect shaking or to move to high ground in the event of a possible tsunami risk. This is an immediate action that's sent via your mobile network. In the medicine industry, practitioners aim to use minimal jargon and to explain risks and side effects. In the food standards industry, for hygiene, typically now is used a 5-point rating system, which we might be familiar with all seeing on restaurants. It's simple and effective, and we know what it means, relatively. And in the motorways industry, on our highways, we're seeing more smart motorways, which are using technology built into the road and within camera systems to immediately alert users of hazards and give them a clear action on what to do, like that shown in the gantry there. So what I believe all these have in common is that they very quickly inform the user and they very quickly give them an action too, in a simple format. So in terms of the different audiences that we might communicate with, in very simple terms, I believe we're probably likely to come into all of these different groups in one way or another through our work. For school children, their knowledge of ground risk is probably quite low or minimal, but they probably have an inherent knowledge of wanting to be safe. And an approach I've found for communicating with children through the ICE Bridge to School scheme is that of storytelling and showing, a demonstration approach. And of course, keeping it quite simple, not using jargon. For students, their knowledge might range anywhere from entry level all the way to becoming professionals at the end of their university careers. So their knowledge can vary quite a lot. But I still think a method of inspiring and showing, particularly through site visits, going out to see the rocks in the field, is important there. And then when it comes to project parties, that might vary all the way from different disciplines that have no real knowledge of ground or technical experts within their own field, but they should all have the same motivator of wanting project success, so they should have an appreciation of risk management. But I think when we communicate with those types of group, we need to summarise, but we also need to carefully inquire so that we can make sure that our ground is not affecting negatively some of their works, or their proposed works aren't negatively affecting the ground in a way that we hadn't already allowed for. So I don't think we should overcomplicate there. And then when it comes to the public, perhaps they have the most variable level of knowledge. There'll be members of the public that are experts and then those that are complete lay persons. And I think some of the appropriate methods of communication with that group would be to use visuals, give the facts, and importantly, involve and engage them, find out how they want to be communicated with, how do they respond. So the key aspect that's missing from all of this is that there's two sides to communication, of course, and we must critically listen and act on feedback to find out how we could do it better and has our message been understood. So as for the future, I think we're faced with clearly a climate crisis. We're going to need to show resilience in the face of that. And if we want to develop some of the slightly more contentious geological solutions, such as deep geological repository of radioactive waste or of carbon, then we're going to very clearly need to carefully communicate what the risks and opportunities associated with that are. And with more growing consciousness around climate change and sustainable materials, we might need to look more at what other materials we can use, such as self-healing materials. As I said, I believe we're in a technological revolution, and I think more models, augmented reality and virtual reality will help us lead and communicate geology visually. And I think remote sensing and machine learning will be able to immediately detect issues and instantaneously give us communications that we can act on. And finally, I think there's a trust problem that we're going to be faced with. Communications are being faced with much more scrutiny and expecting even greater transparency. So I think in this climate of fake news and uncertainty, we're going to have to be very careful on how we communicate. We'll need to be transparent, but also I think we need to be empowered, particularly on site, where if we've got staff on site who are seeing something that's not right or not safe or an unexpected risk of the ground, they need to be empowered to say something and it to happen in an incentivized environment. So they're rewarded for doing so and not penalized. And I think we can give confidence of our skills by professional accreditation and qualification with the likes of the Geological Society and membership of the Register of Ground Engineering Professionals. So to conclude, I think there'll always be a driver for communication, and I believe that this is really the key to success in projects. I think we should adapt our communication styles to suit our different audiences, and I think the sound existing current practice there is well placed for us to integrate some of the best practice examples that I've shown. I think every opportunity can be found in a risk, and I think we're, as engineering geologists, very well placed to meet the challenges of the future, provided we engage with our audiences and embrace the technological revolution. Thank you very much for listening.